we are going to start with the states of matter. Till now, we have already studied about the properties of matter. Now we are going to study about the states of matter. Fine. So till now, you have studied about three states of matter majorly, right? Solid, liquid, and gas. And in class 9th, we are going to introduce you two more new states of matter. But then before that, we have to start with these three basic states of matter, which you must have already studied at some point of time, right? So let us start with the discussion. Do you and also before I start, I will just introduce you to a few terms which you may be knowing and may not be knowing. So today I will first introduce you to a few terms and then we will continue. Fine. Okay, children. So hmm, what is happening? Hmm. Yes, now I can write. Okay, so we are going to study about the states of matter in which the first state of matter and the second and the third is already known to you. The first state of matter is solid state. The second state of matter is liquid state. And the third state of matter is gaseous state, which you have already heard about at least at some point of time. There will be two more states of matter which we are going to study in this chapter. That is BEC, which is known as Bose-Einstein condensate, and the fifth state of matter being plasma. Fine. These are the two new states of matter which you will be coming across in class 9 for the very first time. Most probably everyone must have heard about them for the first time only. So first we are going to start with the first three states of matter, and before we start them we will be studying about a few basic terms which we will come across. So the first and the foremost term which we should all know is the intermolecular spaces. Good evening, Rohit.
Good evening.
Rohit, I've just started with the new topic, which is the states of matter. And I have just introduced that we have studied about the three states of matter, which is solid, liquid, and gas. And in this chapter, we are going to study two more states of matter, which is BEC, Bose-Einstein condensate, and the fifth state of matter, which is plasma. But that we are going to study after we are thorough with all the properties of these.
Yes, ma'am.
Okay. The spelling is not correct. Yes, now it's fine. Okay, children. So before we know about the properties of solid, liquid, and gases, and we start to compare them with each other, we need to know a few terms, out of which the first term is intermolecular spaces. Like if we talk about your school competition also, we do say that inter-school competition means that the different schools are competing with each other in some form or the other. Similarly, intermolecular spaces. What does molecular word refer to? The molecule. It means this term means the spaces present between different molecules. Yeah, just write it this way, that the spaces present between the molecules of an atom is known as the intermolecular spaces, right? And then there is another term which is known as intermolecular forces of attraction. Intermolecular forces of attraction. So what is intermolecular forces of attraction? It is the force of attraction which is present, means the force which holds the different molecules together, the force that holds different molecules, or not just different, they could be same also. So which holds molecules together. Fine. So the forces which hold the molecules together are known as intermolecular forces of attraction. I hope these two terms are clear to everyone. Yes? Okay. So let's move to the next one. Uh, we will be talking about the next term, which is fluidity. Does anyone know what is fluidity? You're aware? It is the tendency to flow. Any substance which has the tendency to flow is considered to be fluid in nature. Now we are going to start with the comparison of the solids, liquids and gases. For that, first and foremost thing is we will see the atoms of solid, liquid and gases. So you are already aware that the atoms or the molecules of solids are very closely packed, or they are very close to each other, whereas in liquid they are a little far apart, and if we talk about the gases, then they are very far apart from each other. So solids are the ones which have very closely packed particles. Liquid are the one in which the particles are a little closer to each other, and in the gases the particles are very far apart from each other. Clear, everyone? Children, next very important thing for you to remember about and not getting confused about the force of attraction or spaces is that I'll give you a very basic example which you can relate in your everyday life also. Children, if you and your best friend, they are in the same class, for example, then your bonding will be very strong. You will have closer attraction, you will be meeting each other more, you will be having more time with each other, so there will be a lot of attraction amongst both of you. But if you and your best friend is shifted to a or we may say that if the teacher makes you and your best friend sit at the same seat in the class, then that particularly bond will be representing solids, you and your best friends. Why? Because since you are so close to each other, you are sitting together, means you are able to bond with each other, you have very strong forces of attraction. But then if you and your best friend are asked to sit at the first and the last bench, then in that case you will have some distance from each other. During the lunch break only you will be able to meet, only during the games you will be able to meet, or only when the teacher is not around you will be able to meet, right? In that case you and your best friend will be acting like liquids because you will have some spaces amongst yourself. Whereas if we shift your best friend to a different section, if your teacher shifts your best friend to a different section only, then what is the possibility that you are very rarely able to meet, then you are not able to interact, then that means that the particles, means you people, are very far apart from each other, and you people tend to behave as gases. Clear, everyone? So you have to remember, if your best friend is sitting along with you, you behave as solids and you have very strong attraction and very strong bonding with each other. But if you and your best friend are sitting a little far apart from each other, then you and your best friend are uh, behaving as liquids and have a little less interaction and little less forces of attraction. Whereas if at all you and your best friend are in different sections, then you have very little negligible interaction, and therefore you tend to behave as gases. Clear, everyone? Any doubts still here? Pranav and Purujit, please turn on your videos.
Yes.
And Purujit,
So basically, solids are close and liquids are a little far, but gases are really far.
yes. And also, another important thing is we will be using some terms while I start giving the definition, the difference between all the three sets of matter. Like we would be saying that it is intermediate in case of liquids. What does this word intermediate means? Means neither it is as large or less than solids, nor it is as large or less than the gases. Means it is in between. Intermediate word means in between solid and gases. Clear, everyone? So let us start with some properties of solids first. So properties of solid state. So the first property of solid is that solids possess rigidity. Possess rigidity. Does anyone know what does the term rigidity means?
Ma'am, they're very strong. They don't break apart.
Okay. It actually, the correct meaning is that the tendency of any substance to maintain its shape even when the outside force is applied to it. Okay. So they maintain their shape even when the force is applied. They maintain their shape when outside forces applied. I hope this is clear, everyone. Then next is, which you are already aware, that solids have definite shape and definite volume. Definite shape and definite volume. Then the third very important property is, I would like to any of you to explain this property to me. I'm just writing and you can explain that to me. Solids do not possess the property of diffusion. Who will tell me what was the definition of diffusion, because I explained twice in the previous class.
Ma'am, can
Harshit, you may go ahead and tell me.
ma'am, diffusion means moving of particles from high concentration to low concentration.
One more definition, who can tell me? Purujit, can you tell me? I gave one more definition. This is one and it is correct also. Do you know, Purujit?
Ma'am, I was absent on that class. I didn't join for like 2 classes in the beginning. So
Okay.
I missed that part.
Problem, you can understand it now. Fine.
Yes.
Yukta, you tell me.
Ma'am, it's basically the intermixing of the particles.
It is the intermixing of the particles, means when the particles mix with each other. Now, when we are saying that the solids, they do not have much spaces inside them, then isn't it obvious that the other solid cannot merge into the solids, right? The intermixing won't be possible in the solids. Why? Because there are no spaces in that. Clear? Like, for example, I was telling you that you and your best friend are sitting on the same seat, means you are solids. If I try to insert one more child into you people, will it be possible? No, you will not like. Why? Because you will say that we have a strong bond, we will sit together. Whereas if we talk about the liquids, you and your best friend are sitting at the last seat, and if we try to insert a few children in between you guys, then it is very much possible in the class, right? So the solids do not possess the property of diffusion. Any doubt in the property? These were a few basic properties of the solids. Also, I'll mention one more property. Solids have maximum intermolecular forces of attraction. Intermolecular forces of attraction.
Ma'am,
Yes.
ma'am, can you once move the sheet a bit up? Thank you, ma'am.
So what does this mean? That they have maximum intermolecular forces of attraction, means the bonding between the solid particles are the maximum compared to the rest of them. And if we talk about the spaces, it has the least spaces. Solids have least intermolecular spaces. Are all the 5 properties clear? If yes, then I'll move to the liquids. Any doubts, anyone? Purujit, Rohit, Pranav, Harshit, Akshara, Yukta? No doubts? Okay, children. Can I move to liquids now?
Yeah, ma'am.
So next comes the properties of liquids. Properties of liquid state. We'll start with the first one. So the first property is liquids do not have fixed shape but have a fixed volume. Fine, children. So liquids, we already know that whatever container we take, we put the liquid, it will take the shape of that container. Whereas the volume remains same. Like if we are taking 100 ml of water, it will remain 100 ml even if we put in any kind of beaker. Fine. Then second property. Liquids are not rigid. I'm sorry. Liquids are not rigid but have the property to flow, which I have just discussed. What does we call this property as? The tendency to flow is? Abhi, I just said
Fluidity.
fluidity. Yes. It is known as fluidity. So liquids are fluids. Fine. Then the third property. Okay, now you people tell me first of all, will the liquids be able to possess the property of diffusion or not?
Yes, ma'am.
Everyone agrees? Pranav? Yes? Yes, of course, we have seen that everything mixes in water, and water is the best example to take as for liquids, right? So liquids possess the property of diffusion. And one more thing I like to add here, that this diffusion in case of liquids is further of three types. So the first one is the solids diffusing into liquids. Example, anyone? Pranav, any solid liquid? Pranav, turning off the video means you are seeing from somewhere else. Akshara, can you tell?
Ma'am,
I'm
they
not sure, but maybe I into like ice cube.
Think of any other solid which you do every day
Um,
and you put some solid into it.
Ma'am, coffee and biscuits.
In biscuit in the coffee. No.
Yes,
Um,
ma'am.
can't say that as an example because we just take it out and we eat it, right? But we can take the most basic example, which is sugar in water or sugar in milk. Got it?
Yes, ma'am.
Example is clear. Then the second is liquid in liquid. Now I think I have given you the hint how to understand. So who will tell me now? Anyone? Any liquid and another liquid is also there. It's very easy.
Ma'am, while making coffee, we mix milk and water, right? Both are liquids.
And water is one example. Otherwise, ink and water is another example.
Ma'am, what about honey and water?
That's also correct because honey is a liquid only. Fine. Then next, the last one is gases into liquid. Again, now this is not very tough because when I will give you the example, you will be able to relate also. So, how do the animals breathe in? How do the animals breathe?
Ma'am,
Pranav and Purujit, keep your videos turned on.
ma'am,
How?
through the lungs.
No, I mean the aquatic animals, the animals which
Ma'am,
stay
the gills, the gills, the gills.
in.
Ma'am, they breathe through their gills, right? If you talk about fishes.
That's the organ by which they breathe in. But they breathe in what? Oxygen, like us.
Yes,
So,
ma'am.
and that oxygen is dissolved in water. So oxygen is water in water. And even you can take the example of carbonated drinks in this case. Why? Because carbon dioxide gas is pressurized into the water, means, or the soda. So that is the example of all the carbonated drinks are the example of gases in liquid. The gas mixes in the liquid. Clear, everyone? Harshit,
Yeah, ma'am.
clear? Any doubts still here?
No, ma'am.
Anyone else? Okay, who will tell me what were the two factors on which the diffusion used to depend? Harshit, can you tell? Harshit,
Ma'am, it could be temperature and
there was one more.
what was
Purujit,
it, gas?
yes, it is density. Very good. Purujit, you need to revise the topics which were done when you were absent in the class, okay? So that you are able to understand whatever I am teaching now.
Okay, ma'am.
Okay, children. So these were the two factors on which it depends. Like, for example, if we talk about the liquid in liquid. So if we if we try to put the drops of ink into water, and if we try to put some drops of honey into water, which will mix faster?
Ma'am, ink as the honey will settle, will not
Denser.
allow the, yes, ma'am.
Liquids, they diffuse lesser, whereas the lighter liquids diffuse faster. Okay. Then another thing, if you talk about the temperature, so I have given the example earlier also. If we warm the milk and try to mix anything inside it, like even if we talk about sugar, then it becomes easier as compared to if we take the cold milk and try to mix sugar or Bonvita or anything. Okay, clear, everyone? Okay, children. So let's move to the next one. Then we talk about the intermolecular spaces between them. So liquids have intermediate intermediate forces of attraction, means less than solids and more than gases. Clear, everyone?
Ma'am, like you gave us the example of the friends who sit away from each other, right, in the same row.
Yes. And the liquids have again intermediate spaces, means what? Intermediate force of attraction means intermolecular force of attraction. Intermolecular force of attraction. Similarly, liquids have intermediate intermolecular spaces, means more than solids. The space between the liquid particles are more than solids but less than gases. Any doubt still here? I hope this is all clear. Purujit, Pranav, Harshit, Rohit, Yukta, Akshra. Any doubts, children? Okay. So let's move to the properties of gases now. So next are the properties of gases. Okay, children. So in the properties of gases, the first property is that the gases neither possess a definite shape nor a definite volume. Means gases neither have a definite shape nor do they have any definite volume. The next, gases have maximum fluidity. Means if we even if we spray the perfume, it has a tendency to go spread as much as possible. Gases have maximum fluidity and least rigidity. least rigidity. And then third property is gases are highly compressible. Means if we put the pressure from outside, then gases are the ones which we will be able to push. Otherwise, the solids and liquid have very less. For example, I'll show you a video also. For example, if we take the syringe, the injection syringe, which we have, if we take 3 syringes, in one we put some sugar, then in the second we put some water, and in the third we put some, we let it be, we don't put anything, air is there. And we put a rubber cork at the end so that nothing flows out of it, right? And then we take the piston and we try to press the piston in all the three. Then in case of solids, we will not be able to press even a little bit, but in case of liquids, we will be able to press a little of it, and in the case of gases, we will be able to press the whole of it, which shows us that the gases are highly compressible. On applying the pressure, they get compressed. So I'll just quickly complete the property and then I will show you the video related to this, or let us see and then I will write. So I think we are going to see this one only.
Can matter be compressed, and how much? Does the extent to which a material can be compressed depend on its state? Let's see. We will need a syringe, chalk, and water. Put the chalk in the syringe and compress it. It does not compress. Now take in water. Seal the opening and compress it. It compresses just a little. Now take in air, seal the opening and compress it. It compresses the most. The distance between individual particles in the case of gases is most, and hence it gets compressed the most. This distance is called the intermolecular distance. Gases also tend to expand and occupy whatever space is available to them. The intermolecular distance is less in a liquid than that in the case of a gas, but more than that in the case of a solid. This allows them to be compressed a little, but they do not expand, but tend to settle down in containers. Solids have the least intermolecular distance, and hence they compress very little. Gases such as oxygen, nitrogen, helium are transported in cylinders in a highly compressed state.
I hope this is clear to everyone.
Yes, ma'am.
The next important property is that gases exert pressure. What does this mean now? Gases are continuously moving. The particles of the gases are continuously moving. Since the particles are continuously moving, they tend to exert pressure in all the directions, and also the pressure is applied on the walls of the container, and we call this as the pressure of the gas which is exerted by them. Clear everyone? So the next property is gases exert pressure, and the question asked to you is, why do the gases exert pressure? So the answer is because the particles of gases are continuously moving. The particles of gases are continuously moving. So since the particles are continuously moving, they tend to exert the pressure in all the directions especially on the walls of the containers also. So the question which comes to you comes in this form only. It is an NCERT question also. We are going to discuss it later. That how can you say that the gases exert pressure on the walls of the container? So your answer is that the particles of the gases are continuously moving, and because of this continuous motion, they tend to hit each other, and when they hit each other, they hit the walls of the container. Clear, everyone? Okay. And then the next property is the gases diffuse very rapidly. So what happens is the gases, if two gases are taken in two different cylinders, we take a cylinder which is kept straight and we take another cylinder which is kept inverted, and there's a lid in between these two. When we remove this lid, the gas which is there in the upper container and the gas which is there in the lower container, they will diffuse with each other, they will intermix with each other, and we will be able to observe that the diffusion has taken place very rapidly in case of gases. Fine. So I will just show you one more video related to this. So diffusion in gases we are going to see.
अगर आपको चाहिए नीट 2024 में एकदम बेस्ट टेस्ट सीरीज वो भी फ्री में तो स्किप मत.
In this lesson, we are going to learn about diffusion of gases. This will help you to understand how gases behave and also explain why smells spread. Before we start, you need to recall what solids, liquids and gases are like in terms of their particles. In particular, in a straight line, smell them outside the box. However,
I want to show you.
The particles in a gas move randomly on all directions. This helps to explain why diffusion takes place in gases. Let us proceed. Soak a piece of cotton wool in ammonia solution, and this provides ammonia gas. Also, soak a piece of cotton wool in hydrochloric acid solution. This provides hydrogen chloride gas. Now plug these two cotton wools in two ends of a hollow glass tube. Cork both the ends, and you will notice that in less than a minute, a white ring begins to form. This white ring is in fact a dense white solid formed by the diffusion of two gases, ammonia and hydrogen chloride. Did you notice that the white ring is formed closer to the hydrogen chloride end? So can you tell which gas traveled faster? Is it ammonia gas or is it the hydrogen chloride gas? That's true, it's ammonia gas. The distance between the cotton wool soaked in ammonia gas and the dense white ring is greater than that between the cotton wool soaked in hydrochloric acid and the dense white ring. From this experiment, we can conclude that ammonia gas covered a greater distance inside the tube.
So I hope this was clear. Like if you talk about the mixing of two gases, the another important thing which we need to know is that the gases which tend to mix with each other, all the gases have their own densities. So the one which has lesser density will move faster, and the one which has more density will move slower. So similarly, in the experiment, we got to see that the ammonia gas traveled faster and reached near the hydrochloric acid gas. So that is why the ring which formed, the product which formed, it was near to hydrochloric acid gas because ammonia traveled towards hydrochloric acid. Clear, everyone? Any doubts, children? And another important example of the diffusion in the case of gas is the aroma means smell. Hot cooked food. Clear, children? Aroma means. And then the next property, which was that the gases have maximum intermolecular spaces. These are spaces present between the particles of the gases are the maximum. And lastly, gases have least, means the lowest amount of force of attraction between the particles. Have least intermolecular forces of attraction. Clear, children? Any doubts still here, children? So children, your homework will remain that you will be learning and revising all the properties which I have taught today, because in the next class we are going to start with the comparison of these three properties. Comparison, I'll just write the heading and I'll provide you with the table in which the comparison is there. Comparison of properties of states of matter. 3 states of matter actually. 3 states of matter. So even if you don't revise, then on Wednesday when I have the class, there is no point. I'll only have to make you revise each and everything. So I request you all to revise all the properties which have been taught today, so that in the next class you're all able to understand the comparison between all the properties. Clear, everyone? Fine, children. So I'll see you all on Wednesday. Do revise. I'll post the PDF also, and I'll see you all on Wednesday. Fine, children? Have a good day, everyone. Bye, beta.
Ma'am, no, ma'am.
Bye.